Hello again. In this video, we're going to go over another example where we use table 410 to find an indefinite integral. But what's unique about this particular example is we have to do some clever manipulation before we can actually use table 410. Okay, so let me show you the example I'm talking about. So let's find the antiderivative of this function. Now at first, you might think to use some kind of quotient rule. But remember, for antiderivatives, there isn't a quotient rule like there is for derivatives. So we can't appeal to a quotient rule. So what we're going to do instead is we're going to factor this 4 out of the bottom. And that's going to leave us with 1 plus x squared. Now, the reason I'm doing that is because we can then pull this 5/4 outside the antiderivative operator since it's a constant. Okay, now we have to find the antiderivative of x squared over 1 plus x squared. And you might look at some antiderivative tables and see if there's a table which would give us this antiderivative. At this point, if you look at table 410, this does not appear in that table. Okay, so here's what we're going to do instead. We're going to take x squared, and then we're going to add 1 to it, and then subtract 1 from it. Which is perfectly legitimate because I'm just adding 0 to x squared, which doesn't change the value of it. Okay, but then why am I doing that? Well, the reason I'm doing that is because then I can break this up into 2 pieces. You have x squared plus 1 over x squared plus 1. By the way, you can write this in any order, right? 1 plus x squared or x squared plus 1 minus 1 over x squared plus 1. And that's because, here you have a common denominator. So if you have a common denominator, you could just subtract these, which would give you this. Or you can go the other way. If I have this, then I can break it up like this. So that's perfectly legitimate. Okay, now, this is equal to 1. And now we can break this antiderivative up across subtraction. So it's the antiderivative of 1 minus the antiderivative of 1 over x squared plus 1. Then all of that would be multiplied by this constant 5/4. Okay, so let's find this antiderivative first. Okay, well, the antiderivative of 1 with respect to x is just x. And that's because the derivative of x with respect to x is actually 1. Right? And so that means the antiderivative of 1 with respect to x must be x. Okay. Now, the second one, antiderivative of 1 over x squared plus 1. Well, that's where we can use table 410. So notice here, the antiderivative of 1 over 1 plus x squared is arctangent of x plus a constant. But don't let this dx fool you. You can pull this dx off, and there's an imaginary 1 left here. So think of this as 1 over 1 plus x squared times dx. Those are the same thing. Okay, so if you wanted to make it look like the table, you can multiply this dx by 1 and write it like this. Okay, so the antiderivative of this, 1 over x squared plus 1, is actually arctangent of x. And of course, you get constants in both cases, right? So let's call this one C1 and this one C2. Okay, but then you have this 5/4 that sits out in front. And so let's go ahead and distribute that 5/4. And then notice that these two here are just two constants. This is a constant, and this is another constant. When you add those two constants together, you get another constant, and I'm just going to call that C. Okay, so the antiderivative of this function is equal to this. Now, if you wanted to check your answer, of course, you could take the derivative of this and make sure that it's equal to this function here. So that's one way of checking it. Okay, so this is a very unique antiderivative. And you'll notice the more we do antiderivatives, the more this is going to happen. Sometimes it does require some clever manipulation before you can actually find the antiderivative. And in this case, the clever manipulation was adding one and then subtracting one, and then breaking it up into two antiderivatives. And then we used the table 410, to find this antiderivative. Okay, so I hope you found this video helpful. Thank you for watching.